is Jeff Lemons, and he came down from Canada. And if you saw previous videos, you saw that this hole has been enlarged, and he's been roughing up the bottom, the base plate. That is the hull of the boat down there, and he's cleaned an area where his DC 144 volt DC air conditioner will be. And then Jeff, what you've done is created another plate for strength.
Yeah,
against the hull.
Yeah. So this is going to get epoxy to the hull, and then I've already put some bolts in this from the bottom up, forming studs that we can just drop our 144 volt unit box right on and bolt it down with some nylocks, and away we go.
All right.
So now we got to find Mike and get him to epoxy this in place.
Okay. Let me go see if I can't find the epoxy king.
And just to do you another favor, before we do that, we're going to put some bolts through here and bolt this thing on tight so that your boat looks good when we're done.
Thank you for the details. Okay, this is his 12 volt, the 144 volt DC air conditioner with the casing off, and you'll see that it's going to have and be set up for the air handler units. Okay, how do you like that? 144 volt DC, nice breaker. Mr. Lemons, hi Jeff, how you doing, man?
Good, good.
Well, last time we were here, we were talking about taking out the AC system that we had that was a blower type, and it was 110. You had to be at the dock or run a genset all the time, and you were talking about putting in a DC genset, and you were going to go back to Canada and build one. Tell us what's happened.
Well, what we've done is you removed the 110 volt AC current air conditioning system with its blower and duct system, and we've replaced it now with a 144 volt DC current air conditioning system that has the potential to carry 5 different air handlers, and it's scattered around this 38-foot catamaran. So what we've done first is stuff our air conditioning condenser and motor box.
Now you took the old one out, and we put a piece of fiberglass down, and
I wanted to reinforce because we're sitting right on top of the the hull that's crossing between the two pontoons. So I wanted to reinforce that a bit and put some screws up through it to bolt our box down. So we did that. Sort of made a new bed for it. Mounted our box. It was a tight squeeze to get it in through the fridge hole here. But it went in nicely. Just had to beat on it a bit. Got it in place. And then we started running lines to various locations we wanted to have evaporator boxes or air handling boxes, whatever you'd like to call them.
So in other words, what do you have back here? You have you have an electric motor in there that runs off of?
We have a 144 volt DC current electric motor that's running a standard sized automotive cell compressor, which is a piston type compressor. This one has 10 cylinders in it, so it's very efficient, and we run it at a speed that we get the most cooling capacity out of it with the least amount of power draw, which is about 700 RPM on this compressor. So this system will put out 20,000 BTUs of cooling, and you've elected to have 5 evaporators or 5 cooling coils in various locations in the boat. Now here you can see we were able to bring all our connectors from the wire harness from the 5 different evaporators right back to this terminal strip where we had inline ATO fuse holders and ground control and power all hooked up, ready to plug in. We also have a relay here for the water pump, which that you supplied, and it's down somewhere in the hold. And
it's a raw water pump for cooling.
Raw water pump. Our 144 volt DC on-off switch. So if you have to service this unit, you want to be able to turn it off at the location so that there's no mistake about whether it's got power on it or not. You can shut it off right here.
And this is a 144 volt DC air conditioner, but a 12 volt control circuit.
Yeah. So the motor that powers the pump, which is what takes the bulk of the power, is run on 144 volt DC. Let's get that around a little more. You see over here is all the fittings for 3 different sets of lines, going 1 to each hull and 1 to the main salon. And they're all hooked up and plumbed in, plus our water in and out and our power. It's basically everything's hooked up with this box already.
Looks nice. Nice and professional fittings.
Yeah, it needs a little bit of neatening and tying up here, but that's not going to get done until a little bit later date.
Right before the boat show.
Yeah, until everything else is done. Otherwise,
so this will be a live air conditioner at the Miami Boat Show.
Yes. So what the key that we're doing, the thing we're doing here is running 2 different voltages to power the system. The 144 volt DC power does the bulk of the work by running the air conditioning compressor. All the air handlers are run off of 12 volt DC current. All the relays and control mechanisms are off of 12 volt DC current. So it's very easy, very safe, very efficient. With this system in our testing, we looked at, we were drawing about 4.5 amps at 144 volts DC, and about, with the 5 evaporators, we could draw up to about 25 amps at the 12 volt DC. So our total wattage use is well under 1,000 watts to produce 20,000 BTUs of cooling.
That's amazing. So
it is very efficient, and 20,000 BTUs of cooling should do a wonderful job on this boat, especially with the air handlers scattered all over, 2 in each hull and 1 extra large one here in the salon.
So the one we'll see in the salon, we'll see that on a later tape, but let's go down here and look at these other air handlers you put down here. This is in the starboard.
What we've done here in this compartment, this is on the starboard, in the starboard hull, right against the exterior of the starboard hull, right about amidships. So we have a bedroom in front of us and we have one behind us. So we've mounted 2 different evaporators, one pointing forward, one pointing rear, in this compartment. They're plumbed in, the lines are teed together, and one set of lines is run back to the evaporator. There's individual wire harnesses that you see here plugged in for each evaporator as well. They go back to the get back to the evaporator. Each one of these evaporators can independently control the compressor system. So if they decide they are cold enough, they will tell the compressor to shut off. So if one evaporator wants refrigerant and one doesn't, the compressor will still run, but a solenoid on the evaporators will control whether they get refrigerant or not. So again, if this one is calling saying I'm cold enough, this one's going to get more refrigerant and get colder quicker.
Okay.
So again, we can be very efficient and very good at creating the temperatures we're looking for in different zones.
Excellent. Okay.
Now if we come around to the interior side, you might say, of that's on a built-in evaporator like that's built into that closet. That's kind of the finished look. Now I messed around and found some old upholstery and upholstered this. It could be painted, it could be whatever cloth, material, paint, veneer you might want to put on this, you can put on to customize it to your specific boat. It comes as just bare 1/8-inch thick aluminum.
So that's definitely a DIY thing. They can do anything they want.
You got to do what you want there, and it's flexible. If you just want the aluminum to show, that's fine. If you want it to be customized to your specific boat, away you go. Now if you look up top here, you'll see the AC lines and wiring harnesses running through and then winding their way back around and down and across to the compressor box.
You've done a good job hiding them.
And that's the key is you can get a very neat, tidy installation, and if you're in this cabin and there's no one in the other one, you can have this AC on and the other one off, and you're being as efficient as you can. You cool what you need and don't cool what you don't need. You're going to have your least amount of power draw at that point, and you can have AC 24/7. Especially if you're under sail and you're regenerating with these electric motors,